Hello, my name is Kawecki. I'm doing this video on space. It's a side never spoken about in today's modern theoretical physics. It's called the Quanta Physics Theory, and it goes beyond relativity and E equals mc squared. As very few know, E equals mc c squared has to do with matter, not space. Albert Einstein's work was very interesting, that he wrote a thesis that space equals time. And he wrote a mathematical formula indicating that. And he made a lot of predictions at the time he was writing his books. Expansion theory was unknown. He said that the universe was static, was flat. Going away from relativity that is based on its own claims, we're going into Edwin Hubble's theory on a round universe. Albert Einstein is famous for what? The atomic bomb, boom, right? And we all know, or vaguely, those that studied it, know what happens to an atomic bomb when it explodes on the planet. For over, 150 miles, nothing but desolate death, disintegration. Well, when we look at that, we can relate that with the Big Bang. The only difference is the Big Bang was a singularity, weighed, measured, and researched by itself, but it happened in space. It was a creation. Big Bang is a creation of our universe, our observable universe. But underneath all that, we have a bubble, as Stephen Hawking might call it. Hubble called it a balloon, that it's expanding. It's space that all matter is cushioned on, and that bubble is expanding at a rate that all the galaxies stay cushioned to its surface. So if you say space has a surface, yeah, of course it has a surface, but it's on a ball. It's on a basketball is a better term, and it's spinning. And why does it have an axis? That's what but all the planets and galaxies seem to be on an axis relative. Now that can be explained because of the round surface. They're on the ball. They're on the skin of this invisible ball we call space. In the Bible, it's known as the void. When you examine the ideas of a nuclear explosion of any sort, or larger, singularity, the biggest bang that ever happened, you have a three-dimensional space. You have a countdown, which is time. But a three-dimensional explosion is a lot different than a one or two dimensional explosion like we have on Earth. That would be considered a two-dimensional explosion, even though it's a nuclear bomb. But you take that into space, empty space, it's a three-dimensional explosion. And to clarify, I think even Edwin Hubble clarified this, that the explosion and the matter that was formed or created during this explosion was three-dimensional, or four-dimensional if you want to say, because that's t equals 0, but when it exploded, it was 360 degrees, leaving in the center a void, a space, part of the empty space, zero-point energy space, as an element. And when everything shrunk back after the explosion, see, space has a density. It allows something to expand, but it brings it back. It's flexible, like a rubber band. You pull it, and it's going to go back. Well, when this happened, the void in the center, the space, became concentrated, the same way that matter became concentrated on its own. It became instead of just matter, it became energy mass. Or energy matter first, energy mass. And it became concentrated. And why is the universe expanding? Because the concentration is coming out of the cells, if you want to call it the cells, of that space, the equilibrium, the space element itself. And that is what's causing the universe to expand. I've read a book, hopefully it'll be out pretty soon, but To the End of Time and Back, and I explain all this from t is 0 to an expansion rate and an expansion time table. That even though it's really unpredictable because the universe is expanding. It's expanding at a specific rate, and it illustrates how fast. If space is gravity, and gravity, even though invisible as a void or a balloon or a bubble, is expanding, that means all the matter that lays on top of its surface is like cushioned into it and it causes it to spin. So those are all our galaxies. How long this will go for cannot be probably predicted, but the density of that expansion, known to be a force of gravity, relativity in reverse to Earth gravity, matter gravity. So we're talking about space gravity, in the center of our from the center of our universe is expanding, making all the matter spread apart, as Edwin Hubble's universe hypothesis tells us. I've discovered the degree, how fast it's traveling. It changes the age of the universe. It changes the whole thing because it's not a flat universe. A flat universe floats in space. It might be round like a pizza, Vortex came into the picture when we talk about spin, and then the hole in the center that was created because it is spinning. No explanation to the axis of the planets, the stars, the galaxies. And the round universe, the basketball universe, that's at a spin. Causing all the galaxies to rotate and to it's around, let's say, basketball, whatever. You put a piece of matter on it, it's not flat, it's not straight. There's a curvature of this balloon, Hubble's balloon. And it's strange why everything in the universe is round. All the planets, stars, and everything. Yeah, they got mountains and everything, but specifically they are round. And why is this? I don't know if I gave an exact explanation of why everything seems to be round. We got the early universe, the young universe, the elements that were formed, the chunks of matter, and if they're spinning, they're not flat. They're round like the equivalent, or space, is actually oxygen oxide. It's cold, creating like a refrigerator. It's cold. The matter in it, the suns, no matter their size, is the heat. And the heat from these suns is what warms the planets near them. Or makes the distance makes them cold. That's why they call Earth the perfect blue planet. But in essence, this video is about a round universe. It changes the speed of light. It changes the age of the universe. It changes the physical structure of the universe. It tells a story about a round universe, a void that was formed from the Big Bang. It even tells what happened and where that void came from and why it proceeded. But anyways, to the end of time and back. Think about it. The evolution of the universe, the life expectancy of mankind, of planets, of a universe. But a universe so huge it's unimaginable. Anyways, I hope you like my explanation. It goes a little bit beyond Hubble and gives a theory about what that space might be made of, or been made from, and why the universe is expanding. My name is Rod Kawecki, and I hope you understand and like my video. Bye.